Okay, today's video is on particle motion practice. So number 1 reads, a particle's velocity at any time t is given by the function v of t equals 4t squared times sine t to the third. So this is the velocity function. Okay. Okay, and number A reads, find a particle's acceleration function in terms of t. So as you know, acceleration is velocity's derivative, because acceleration is basically velocity over time, or change in velocity over time. Okay, so since we have v of t equals 4t squared sine t third, a of t would be v prime t, or derivative of 4t squared sine t to the third. So since this is 4t squared times sine t to the third, we have to use product rule. So first, derivative of 4t squared would be a t, and then times original second part, which is sine t third, and then plus sine t third derivative would be 3t second sine, cosine t third, and then times original first part, which is 4t second. We can try to simplify this a little bit. So 8t sine t third plus 12t to the fourth power cosine t to the third would be the acceleration function. Acceleration function in terms of t. Okay, and then it's second part is the particle's position function in terms of t. So position function is actually the integral of v of t, the velocity function. Position is integral of v of t, because velocity equals change in position over time. Okay, so v of t again is equal to 4t to the second sine t third. So s of t, or position, would equal v of t integrated like that. Okay, that means integral of 4t squared sine t third dt would be the s of t function. And in here we can see that we can use the u substitution to integrate this. So u sub of t to the third power du equals 3t squared. Okay, and then we're gonna divide each side by 3. So 1/3 du equals, dt here, equals t to the second dt. Okay, and then we're just gonna replace the t to the second with 1/3 du. We're gonna take the 4 outside, so outside, and then sine u du. And then integral of sine would be negative cosine u. So negative 4/3 cosine t to the third plus c would be s of t. Okay. Alright, and then if you have a given initial condition, then you can plug that value in to see what value of c would be included in the position function. But then we don't have that right now, so we're just going to skip that part. But if you're given like an initial condition, like the position at t equals blah is blah, then you can, like, if the position at t equals 0 is actually at like 5, then you can plug the t 0 into this equation, and then 5 into s of t to find the value of c. But then right now we don't have that, so we're just going to skip that. And then c asks, at time t equals 4, is the particle speeding up or slowing down? Prove your answer with an explanation in full sentence with numbers. So in order to find out if like a particle is speeding up or slowing down, we need to see the sign of the acceleration and the velocity functions at t equals 4. So v of t again is 4t squared sine t third, and then acceleration is at 8t sine t third plus 12t fourth cosine t to the third. Okay, and then we're gonna plug in v of 4 to t for each of these. So plug that in. Make sure to use radians for sine here. So 4 times 4 times 4 times sine 4 to the third would give us 50, I'm gonna use approximation, 58.88, which is greater than 0, so it's positive. And then for BC, make sure to use 3 decimal places. And then A of t, or A of 4, oops, sorry. 4 would approximately be sine 4 to the 3 Okay, this one would be approximately which is also greater than 0. So you can see that the acceleration and velocity are both in the same direction. They're in positive direction, or they're positive, so they're in the same direction. So that means that this particle is speeding up. Okay, so for our explanation, we're going to say at t equals 4, both velocity, v velocity is, do we have units? No. And acceleration meaning both and velocity are in the same direction at t equals 4, the particle speeds up. Okay, so this would be our explanation. And then going off to part D, interpret the meaning of the expression integral 0 4 v of t absolute value dt. So absolute value of v of t, or velocity, value of v of t. This means that you are getting the speed, right? Speed is magnitude. Speed is magnitude. And doesn't include no direction using positive or negative like velocity does. Okay, so speed is essentially the absolute value of velocity function. So whenever you're seeing this, that means you're trying to get the speed. Okay, and an integral of speed is actually really interesting because usually integral of velocity gives you the position function. or like this is the displacement. But then v of t absolute value, so integral of speed gives the distance function, like the distance traveled. Yeah, so the meaning of t is the distance traveled between by the particle for the first 4 seconds. Okay. Yeah, and then this difference between displacement and distance is that if you traveled like here to here to here, then like the displacement would be the difference in the starting and the ending point. So this would be displacement, and the distance would be counting all of these lines and curves, so counting all the curves and the paths that you took. So basically the length of this like squiggly line would be the distance traveled, which is given by the integral of v of t, and this one's given by the integral of v absolute value of v of t, and this is given by integral of v of t. Yeah. Okay, I think that's about it for part D. Okay, and then E asks at what value t from 0 to, this should be 2, not 4, is the particle most to the left. Okay, so for this one we're going to use the graphing calculator. So on your graphing calculator, make sure to graph the velocity function. So the velocity function was 4x squared sine 4 to the 3rd power. Okay, make sure the mode is in radians. And then we're graphing this right now, and then we're going to set the boundary as 0 to 2 in the window panel. So x minimum would be 0, and then this would be 2. The maximum would be 2. Okay, so from here we can see that v of t is 0 when t is equal to 0. Also when t is equal to, let's trace it. Okay, and then also when it's equal to 1.465, and when t is equal to, second trace, and then when it's equal to 1.845. So these are when t would be equal, v of t would be equal to 0. And then on a number line, let's graph these values. So 0, and then we also have 2, and then we have 1.465 and 1.845, right? Okay, so from 0 to 1.465, the graph is positive, okay? And then from 1.465 to 1.845, the graph is negative, and it comes back to positive once more between 1.845 and then 2. So it's like that, and we can see that from 0 to 1.465, the particle was moving to the right because it was positive. It was moving to the right, so it's like t equals 0, t equals 1.465. To the left, and then it's going to be moving a little bit to it was moving to right and it's now moving to the left because t.14 yeah, and then 845, and after reaching t equals 1.845, it also goes to the right side again. So it says, when is the particle most to the left?